Did it go? There it is. Okay, so we've got multiple examples here that we're going to work together. Okay, and you will see that 1 and 2 are going to be similar. Okay, 3 and 4, and then 5 and 6. So you're going to have 2 examples of each type of problem. Example 1. If there are 950 grams of barium and 26.3 grams of fluorine in a compound, what is the percent composition? So let's go back and look at the formula I have written on the board. Percent composition equals mass of the element divided by the mass of the compound times 100 for your percent. Okay? Everybody caught up with me? Okay, what did they give us? Now here's your analysis part, kids. They gave you mass of who? Okay, so this is one of your individual elements, isn't it? We don't know the compound formula, but we have masses of the 2 individual elements, and then we have the grams of fluorine. Okay? Now then, my formula says mass of element divided by mass of the compound. Well, does it make sense that we can add the 2 masses because it's only barium and fluorine in the compound? They've already done the analysis. Can we add the 2 masses to get the total mass of the compound? Yes. Okay, so right over here off to the side, that's what we're going to do. We've got 95.0 grams plus what? 26.3 grams. Very good. Okay, now what did we just find?
The total mass of the compound.
Yes. Okay, so this is the mass of the compound.
This is actually, I mean, if I did it right, this is super.
It is. Extremely easy. Now, following this formula, kids, take the individual mass of the element, divide it by the total mass of the what? Times 100. So we've got 95.0 grams, okay, divided by 121.3 grams.
Ends up being something like 78.3182. I just put 32.
Yeah, and I'm sitting here, I debated as I worked this out yesterday on using significant figures, but I decided not to do that. I think I want to run with maybe just 2 decimal places in our answers. Okay? So, basically, let's use 2 decimal places in your answers. So, y'all do the math for me, because I use significant figures, and
78.32.
so I have 78.3, and I need to add the 2.
78.32.
Okay. Alright, so then we're going to use the other one, 26.3 grams divided by 121.3 grams times 100. And 1 decimal place, I have 21.7. What goes? I'm sure I rounded there.
Yeah, it's going to be 20. Go back.
Yeah, everybody get your calculators out and use them for me, please.
68.
21.68?
Yes, ma'am.
Yes.
Okay. Now then. Now can you see that the second example is going to function what? What do we have to do here? Let's read. They gave us the total mass. Does everybody agree in the first part, the first number?
Yes.
Because it says 225 grams of a compound. Okay? That goes with that. Is known to contain only who? Phosphorus and oxygen. And 114.3 grams goes with who? Okay, that's right. Okay, so they want to know the percent composition of each element. So we know our oxygen is going to be 114.3 grams divided by 225 times 100. And kids, we need to label these. Let's go back and put, this one is BA and this one is F. So there's no question. This one's going to be oxygen. Okay? And then phosphorus, we'll do our subtraction and get the other mass. So do your math for me, please.
110.7.
Okay, is that the calculator answer?
No, I got that hand.
Yes, it is.
I got a,
50.
I got 50.8.
Yeah, I got 50.
yeah, the answer's 50.8. He just gave us the other value. The 110,
That's what we were talking about.
my bad, the 110.7 grams is going to be the other value, kids. Yes, and y'all are right. Yeah, so 50.8, is that the calculator answer?
Yes.
Okay, and so the phosphorus, what'd y'all get?
49.2.
49.2, is that the calculator answer? Okay. Okay? So if your calculator spits out, I'm not going to be picky about your answers. You see, I only wrote one thing here. If the calculator spits out 1, I'm not going to require you to put a 0 on there. Everybody understand? When it spits out things that are like 5 miles long, round to 2 decimal places. All right. Yes.
So we'll have 2 answers on every problem.
Oh, that's,
Just don't work that like that.
yeah, unless there's more elements in the compound. Does that make sense?
Gotcha.
Okay, and I don't think there are, so that these will be pretty much standard. All right, now here's the next set. Now then, do you see that they gave you no numbers?
You gotta find the mass of the
Okay, first we have to write a correct what? Yes? K plus 1, SO4 minus 2. Crisscross, who gets the 2? Okay, so there's our formula. So here it goes back to yesterday's work. How many K's do you have?
2.
Now you're going to have to write small. This gets a lot of work in a small area here. So I've got my K is equal to 2 times how many? 39.098. Which equals, and I'm just going to go ahead and spit out the answers here for you. 78, since y'all know how to do it, 0.196. Okay? All right, next is S. Is 1 times 32.066, which equals 32.066 grams. And then we have 4 O's. 4 times 15.999 grams is equal to 63.996 grams. And we total that up and get 174.258. Okay? All right. So that's exactly what you did yesterday on yesterday's assignment. Everybody agree? Okay, now here comes the added part. According to the formula, I'm going to take the what? And divide it by the total mass. Now, if you look right here, this is the advantage of doing it this way. Do I already have my element's mass? Yes. So my K is equal to 78.196 grams divided by total mass was 174.25. Let me make sure I'm not, 258 times 100, okay? So when you divide that out, I got 44.87%. Yes? Okay. So S. I've got my individual is 32. Everybody see that? So 32.066 divided by 174.258 times 100. I got 18.40. Yes? Okay. And the oxygen is 63.996 divided by 174.258 times 100, and I got 36.72. Yes? And if you would, it is advantageous for the people that grade your work if you do what? Box those answers, please. Okay? Especially when you start getting a whole bunch of junk going across your paper. Now then, example 4 will work the same way. I will come back and do it if I have time. What time is it? 49. I'm going to drop down to example 5. Okay? Because these are different. So 3 and 4 work identical. What's the correct formula for NH? Let's do the formula right here in case I don't get back to this one. What is the polyatomic ammonium? NH4 plus 1. And phosphate? PO4 minus 3. Crisscross? NH4, 3, PO4. Yes? Okay, so there's your formula. All right, let's go down here and look at example 5. Calculate the mass of iron in grams present in 250 grams of iron 3 oxide. First thing that we have to do is write a formula. What's the symbol for iron?
Fe.
What is the Roman numeral 3 telling you about iron? Exactly. If you can't answer that from last semester, you haven't learned squat. Oxygen, -2. Crisscross, what's my final formula?
Fe2O3.
Okay. All right. They are looking for the mass of iron present in 250 grams of iron oxide. All right. First thing that we have to do is get the total mass of iron oxide. Does everybody agree? Okay, so that's the first thing we're going to do. My Fe, I have 2 of them. Iron is 55.845. Okay. Which equals 111.69. Alright. My O is equal to 3 times 15.999 grams, which is equal to 47.997 grams. Okay, my total mass for iron oxide is 159.687. Okay, so you know how to do that part. Now then, I have to find out what is the percent of iron in iron oxide first. So I'm going to do the individual part. So I'm going to do iron only, 111.69 divided by 159.687. Does everybody understand they're only concerned about iron?
Yes.
Okay, so this is our iron. Alright, times 100. And I have 69.94%. Did y'all check my math? Okay. Now, everybody good so far? Now, this is what they have of iron oxide. So I'm going to take the decimal number of the percent. What I just say? So I'm going to move my decimal back, take it out of percent. So 0.6994 times the 250. Very good. And I get 174.85 grams of Fe. And that's your final answer. Okay? So let's do number 6. It's also like number 5. All right? So the first thing we have to do is write the formula. Zinc is Zn, charge is +2, carbonate is CO3, -2. 1-to-1 ratio, so what's my formula? ZnCO3. Okay. What was the first step we had to do?
Find the masses of the different elements.
Yes, so we've got to find the mass of zinc carbonate. Okay, the different elements, just like we've been doing. So Zn equals, there's only one of them, which is 65.38 grams, which equals 65.38 grams. All right, carbon. There's only one of them at 12.011 grams, which equals 12.011 grams. And then we've got oxygen, and there's 3 of them, times 15.999 grams, which is equal to 47.997 grams. totaled up, I get 125.388. Okay. Now, what's my next step?
You divide
Oxygen.
oxygen by the,
Total mass?
of the compound.
Yes. Okay. Very good. Because that's all they're concerned about. So my mass of my oxygen is 47.997 grams divided by 125.388 grams times 100. And I got 38.28. Is that right? Okay. Now my next step was to move my decimal back, take it out of percent. So 0.3828 times what was my grams given up here? And what'd y'all get? 95.7 grams of who?
Oxygen.
There you go. Think you can handle that? Now what's your assignment?
All of this.
Yours is odds. Pre-AP is odds, regular is evens. Okay? Alright, if I were you, I would go through and circle all my odd numbers.
On this one, I gotta just point one off, literally just point one, just click on one, but it was, dang it, I got to redo the primary, but it was 0.1 off, all this adds up to be 0.1.
And it will because of the rounding.
Yeah, so just
Now
that's
kids,
fine.
yes. Kids, you're gonna find that some of them, you're gonna be like a 0.1 off. It won't total completely to 100%. Where is the error coming in? In the rounding. When you round that final answer, remember, use all of your maths off of the periodic table. But when you go to round that final answer, there is your error, okay? And I'm not gonna make you use those 50 decimal places out there. So it will come up right at close. You'll either be at like 99.99% or you'll be at 100.01 or something like that. You'll be really close, okay? Yes. Oh, let me turn off my.
One.